Hello, my name is Jakub Stępień and I'm a software engineer at CodiLime. Today I want to present you a tool called Garden, which calls itself as an architecture as a code tool. We'll talk about what this tool is and why there are cases when it is helpful to be equipped with such tool. And we will also try to use it with some simple application. But let's start with a little background, why we might need such bit of a software. In the last 10 or 15 years, there were significant changes in software development process. Most of them driven both by new technologies and growing expectation regarding time from idea to deployment. We experienced transformation from waterfall to agile. We started automating our tests on all levels. We have applied microservices architecture, and we had fallen in love with DevOps initiatives and principles. And finally, we abandoned the once, twice a year release approach in favor of continuous integration and deployments. We moved from own infrastructure to on-premise and finally to cloud computing. And it looks like we have all we need to code and deliver with light speed. Like we have all these agile goodies. We have many remote collaboration help us. We have ways, techniques, and patterns to split our software into smallest units that can be developed and delivered independently. We have many powerful tools and IDEs, and we have Visual Studio Code. Anyway, the point is that now we should be able to develop, deliver, and deploy as fast as possible, as fast as ever. But are we really into DevOps, or have we just changed names of the teams and responsibilities because now both devs and ops have different tools than previously? Do you as a developer know how the environment on which your software is deployed looks like? Or can you easily set up such environment by yourself, locally or remotely? Is there a so-called DevOps team in your organization that you have to reach to anytime there are any problems with accesses, for instance, or with the pipelines that your software tests are run by? So the question is, do we really have all the bits that happen from coding to deployment working really smoothly? Are they well integrated and understandable by all involved parties? We all want to live in a world that is as close as possible to ideal one, where developers know how to build the environment, or they have tools to spin it up easily, so they are able to reproduce real end-to-end scenarios or test the integrated software with fast feedback loops. So I think there is still a place for tools such as Garden. We already have few of that kind, like Scaffold or newest DevSpace or Teal. But perhaps there is something that Garden do better, or it has something that other tools do not. Let's find out using some simple application. Okay, so before this presentation, I have installed Garden using installation script from Garden IO web page. And at this moment, I have Garden installed in version 0.13. I have also created local Kubernetes cluster using kind. This is simple single node cluster. So after installing Garden, there is Garden command line available with some subcommands. 3 of them are direct representations of Garden concept, which is based on having 3 actions, which are build, deploy, and test. There is also one more subcommand, Garden dev, which will start an interactive shell where we can execute all of these and see logs in real time. But let's start with creating our project configuration. To do that, there is a command create project, which will ask us about project name, and it creates us this project.garden YAML file. Let's open it up. Here we have our project specification, So we have specified default environment, which will be used by the garden. There is a list of environments which we can configure. Let's focus on a local one, and actually let's make it a default environment. So we can also specify the default namespace that will be created on a cluster, etc. And also important things are providers. We are using local environment, so we will be using local Kubernetes provider. Description of that providers you can easily check on the Garden.io documentation, but mainly providers are the bits that actually instruct Garden how to connect to our infrastructure and what resources can be created and how. After creating this file, we can actually run Garden dev shell, or we can execute just Garden build, for example, subcommand. Perhaps let's use the this approach. So what it does, as we don't have any other configuration than this initial project one, this will initialize some default configuration for the Garden itself, for Garden resources. And by default, for the local Kubernetes, it will also create it will create ingress for us. That can be, this behavior can be switched off in the project configuration. But anyway, application we are using needs the ingress. So let's keep it as it is. Okay, let's see what we have here after that. So we have this Garden resources, and the rest of it is just vanilla Kubernetes resources. All right. So our application, which we will be using, is built with 4 services: database, main backend service, some additional API server, and the front one. Let's focus on the backend side, and let's start with the database. So to create a Garden configuration for any service, we need to create garden.yam file. And we need to specify actions we want to be executed for that. So let's start with building our service. So that will be build action. And there are some configuration keys you can check on Garden documentation, but we can specify name for the action. So that will be an inner Garden ID for that particular action. Let's call it database. We can specify the description as well. And we need to specify a type for that action. So there are action types like execution, container, or Kubernetes, and some are built into Garden, some are defined by the providers. But as we want to build image locally, let's use type container. And there is also key called spec. So that will be specification for that particular action type. We can, for example, specify local ID, which will be the image name that will be built. By default, if this is not specified, it will use the action name for that. But let's maybe specify it. Let's make it a proper YAML as well. And basically that's simplest configuration for the build of that service. Let's perhaps run the garden dev shell and execute build command. That should build us a database image. Let's check if it is created locally. Yep, we have our CodiLime DemoDB. Okay, so the next thing we want to do is actually deploy our service. For that, we have action deploy. And again, we need to specify the name for that action, as we want this deployment to be on Kubernetes cluster. This time we will be using action type Kubernetes. And again, things like description, and we can also specify dependencies. So for that action, we want to have image build. So this syntax means that Garden will look for the DB action from the build type action called DB. Then what else we need for the deployment? We need to specify our actual deployment configuration. So we need to provide a path to our manifest or Helm charts. In case of Kubernetes action and kind deploy, we will be using a manifest. So I have manifest for the DB. Oh. Then we need to tell Garden actually what should be used for, like grabbing logs or code syncing, etc. For that, there is a key called default target. We want to specify deployment. Actually, it might be, for example, also pod, etc. But I want to use deployment. So name, we need to double check the actual name from in our manifest. Let's find it. Manifest, and that will be our deployment name. Actually, let's open our project configuration as we have specified project name here. We can use it. And we can build our images with prefix taken from that project specification. Okay, one more thing we need to do, as we can have like specified some specific image name, registry, repository, etc. But we want Garden to use images that we build here. We need to specify key called patch resources, and we need to actually also patch our deployment. And update the image that is going to be used. So those are keys from manifest, right? And we want to use image that was built in a build action. So to do that, we need to tell Garden that, hey, let's use action build db and output, because like all of those actions have also outputs. You can check that on documentation. One of the build output is the image ID. If I get that right. So we provided action build db, and we want to take the deployment image ID from output. I hope I get that right. So let's fire the deployment. Oh yeah, that's deployment image. That should be fine now. All right. Looks fine. And we have our database deployed. And now we can do the same for the other services as well. To speed it up, I created previously Garden configuration for this to-do service and API server as well. So for the API server, I want the image to be built, of course, and I also want to-do service to be deployed. And additionally, we want to deploy our ingress configuration. For the to-do service, one of the dependencies is database being deployed. So let's run that deploy Garden. That will build our images and deploy them on a cluster. Let's check if we have that right. So yeah, we have all 3 backend services deployed. Okay, so let's verify if it's working correctly. Let's actually send some requests to this application. Our ingress will send a request to our services when the path is this one. And our API server has this endpoint health check. So yes, let's use that. Okay, looks like it's responding correctly. There is one more action in Garden. This is test action. So at the moment, we don't have any tests defined here. So let's add some. We have created our backend integration tests. There is a Docker file to build the image and Docker Compose to run it. Okay, so to actually, previously we created Garden YAML files in all those services directories, but we can easily create so one at the root level. So for our integration tests, we want to build the image, and our Docker file is expecting to have this build argument provided, so we can specify it here as well. So now what we need to do is to build the actual images, and as we can see, our integration test image is being built. Now it's done. Okay, so we can add specifications for our test action. So we want the application to be deployed, and we can use a different action type this time. So for the test, I want to use the execution type, which is executing the local command, which can be specified here. So I want to use this build image to run Docker with such command. Okay, let's run the test. Let's save that probably. And we have our test execute. I'm pretty sure there are some additional tests there as well. So let's create one more test action to run different set of tests, for example. When I run test now, it will run 2 test cases. Okay. It's looking fine. Okay, let's try to introduce some bag. For example, we have our API server, and we have our response for GET request. So perhaps let's just return an empty list here. So now when we run our test, Garden should actually rebuild and redeploy our API server service, and then run tests, which at least one should be failing. And yep, we haven't. Oh, so far so good. Let's fix that. There is one more feature I want to show you in Garden. It's for live updating. So instead of rebuilding and redeploying, we want to synchronize just some files that were changed. Let's use our to-dos service for that. And let's check the Docker file first. So in our Docker file, we have specified the command to start the server. And in Garden configuration for to-dos, we want to specify sync key under deploy action, and we provide source path inside the container, what mode of synchronization we want to use. In our case, I want to use one-way replica. And what's important, we need to override the Docker file command. So instead of just running server, we want to monitor our .py files, and in case of any changes, then rerun the server again. Let's save that. So in Garden, there is sync command, so we can check if it is in sync mode. At the moment, we have a sync defined for one application, one service, but it's not active. Okay, so let's start it. But we need to redeploy this particular service. So let's add deploy. Now, when we see the status, we have sync active for this to do service. So at the moment, there is one item created inside our application. So we can test the synchronization by just introducing some bag. So instead of returning correct items, let's just return an empty list. That should do it. And let's see if it's, yep, now the response is empty. So yeah, that's quite useful. Okay, now it's updated and it should start returning correct list again. Okay, so let's go back to our project garden configuration, and we mentioned all those environments we can configure and use. So by default, we are using the local one, but we can also use, for example, ephemeral one, which is hosted on Garden.io. And to use that, we need to authenticate ourselves on Garden.io with GitHub account. I already did that. And one more advantage of this authentication is that we are able to see our project and all commands we executed for that project. And the link when you authenticate yourself, so using Garden login, you are provided with the link to this project on Garden.io. So we have all the commands we executed here. We can check the logs as well. And there is this ephemeral cluster bit here. And we are currently not using any ephemeral clusters, but we can use one actually. And there will be one more thing I want to present you today. So we have this garden configuration on root level. We can add here one more bit, which will be workflow action. So that's the fourth. We have actions, build, test, and deploy, and there's this another one called workflow. And again, we specify the name for this action, and for the workflow type, we can specify steps. So like, for example, we want to build all the images, deploy them, and then run tests. And at the very end, we want to clean up the cluster from this deployment. We can specify, of course, some conditionals, like, for example, we don't want to run this cleanup step on our local environment. So let's move to our Garden dev shell, and to run workflow, we need to provide the workflow name that will run this workflow locally. But we can also run it specifying environment. Okay, so it took some time because we are using this cluster and environment for the first time. Garden needs to initialize all the resources from scratch there. But anyway, it failed at the very end. Let's see what happened. We can use the dashboard for that. So as we can see, our test action failed. We can check the logs. So basically, it had a problem with finding the image for our tests. But anyway, as it's stated here, this feature is still experimental. So yeah, probably we'll check that in some time. And regarding dashboard itself, beside the commands and the whole history of execution execution for that project on any environment, there is also workflows tab for that. But as you can see, it's only for enterprise users. The same for cleanups, cleanup runs, and any other bit here. So for the users which are not enterprise, the only thing is the commands and FMR cluster here. So if that was interesting enough, you can learn more from the official documentation and tutorials. But my impression is that there is no really added value comparing tools like Scaffold or Tilt, at least from developer point of view. So if you are already using one of the other solutions, then there is no actual point to switch. But if you are just planning to use something like that, then go check Garden as well, and its documentation and features, as we covered here just the basics. And then choose one that you or your team feels comfortable with, because that is one of the points, right? And perhaps you really want to use features of Garden Enterprise Plan, or when you decided to use Garden platforms and its functionalities like on-demand preview environments, so you are able to create environment per branch, commit, or PR. Or you think that it is a good idea to merge some of your other stacks as well, then Garden can cover that with, for example, Terraform plugin. But just keep in mind that Garden is still in 0.something version. So there are features that are still experimental. Some might change in the future or might be deprecated. There can be some bugs not found yet. Or you might need to debug why something is working on one environment and is not working on the other, like we saw in the workflow example. But still, Garden provides a fresh look at the development environment and deployments. And it's trying to cover the gap between dev and ops, which still exists. And it provides unified tool and configuration. Due to that, there are many features included, and it looks like Garden trying to be an army knife scissor for anything that is related to Kubernetes application development, integration, test, and deployments. So it might be a bit overwhelming to go through all of it at once. But if you are starting a project, then it could be a good thing to give it a try, just to know that there is such tool out there, and it might happen that you will have a use case that it can fulfill. But in case of just ensuring your development environment, especially the local one, I think it is still better to use some more mature tools with bigger community. That's all from my side today. Thank you.